Cock-a-doodle-doo, everybody. This is the first video for day 5, where we'll be focusing on lists. We defined a bunch of different kinds of data structures on day 4, and we'll be focusing over the next few days on a couple of like particular instances of them. So we'll start by talking about lists. I've got a plan for about 6 videos. It'll probably be 6. Reserve the right to change that number as we go. Don't think there'll be any whiteboard videos this time. But if as you're watching the videos there's something you'd like more on, I really want you to feel free to ask for more on Zulip. I'm happy to talk more on any topic you like. Probably should be computer science related, but we can work stuff out. So just give me a holler. Drop me a little @ on Zulip, and we'll find something to do in a nice new video. Okay, lists. Lists are really important. Lists are probably the most important data structure in that they show up absolutely everywhere. It's worth starting out just thinking about what constitutes a list, and a list is just some sequence of things. We saw they were constructed with the constructors nil and cons, and we defined polymorphic, that is lists that could hold different values, homogeneous, your choice, lists, meaning that any given list only hold values of one type, but you can have different kinds of lists. That's what we defined on day 4. We're going to start out today by defining some better list notation. So I hinted at this possibility in day 4 when I wrote some concrete syntax in comments with square brackets. And let's just go ahead and define it. It's super nice to have good syntax here. So we're going to define a couple of bits of concrete syntax. The first is this notation, the double colon for cons. So this lets us write things in a fairly concise way. This is also the notation that the language OCaml uses, and OCaml is the language that Coq is implemented in. It's worth sort of being careful here. This is 2 colons in a row. You can't put a space or anything between. Just 1 colon, and Coq thinks you're talking about the type of a thing. So you might get a really weird error message saying like, why isn't a type? It's a list or something, if you miss one of the colons in your cons. Great. The empty list will denote this way, 2 square brackets, open and close, an open and shut list if you like. Okay, and then Coq's notation facilities are pretty fancy. Like the dots here are saying and so on. And that to me is really impressive that it can figure out what we mean by this and so on. I'm sort of shocked. But what this means is that for a concrete list where we name all of the elements, x, blah, 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 all the way through y, that turns into cons x, blah, 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 cons y, nil. Right, so we're just, if you know all of the elements of the list, you can just name it with these square brackets. And lastly, because it's such a common thing, app, the append function, will make that into just plus plus. In some languages, like say JavaScript or Python, plus on strings, just like plain arithmetic plus, will be the thing that concatenates 2 strings, or lists or what have you. Here we'll do plus plus. It'll be a different operator. So this is a sort of common convention to do plus plus. Okay, so let's walk through a variety of different ways to write the list 1, 2, 3. Okay, this is the maximally verbose one, where we're using the @ symbol to turn off the implicit arguments and insist on writing nat 4 times. We must be from DC. Why else are we writing nat so many times? Also, congratulations to them, 2019. Okay, here we make it explicit and then we underscore out the types. Okay, that's sort of a weird thing to have done, but you know, you do you. Okay, this is sort of the way we ended up by the end of day 4. Okay, we don't have to write the types every time. It kind of works itself out. But look at this. Look at this. That's nice. That's clean. I mean, we could do other ones too, right? List 1, 2, 3. Woo. And we could do something like this. Right? These are all specifying the same list, and I should make it clear you don't need space here. Though I think some spaces are typically nice. You don't need space. And you can have, extra space in here and so on, stuff like that. Right. So the general idea, and I'm sorry about this, I don't know why the renderer keeps doing this. The general idea is that you write down all the concrete elements of the list in these square brackets, and that's just like doing all the conses and then the nil. A super common mistake people make when they're learning this notation is writing nil as the last thing, or thinking it needs to be in there, or thinking you can write a list here and have that be the tail of your list. It does not work that way. You're naming only the elements of the list. You can't put a continuation of a list here. If you want to just cons a bunch of things on the front, then use this double colon notation for cons, or if you really like, use the plus plus notation to put it on there. So here's another one. right? All these are the same list. Okay, so there's a couple of quizzes here. I want to stress one thing before we really go into these quizzes. The square brackets here are like list brackets and not this is a cock expression inside a comment brackets. And it's just like a really unfortunate thing that like we use the same notation for both and it's not clear really what we should do about it. So like here we are. So in the quiz question, those square brackets are talking about the list. And then in the answers here, those square brackets are saying we're talking about a cock type or expression or something. Okay, so the list 1, 2, 3. What happens? Pause the video if you like. Maybe you just unpaused. Okay, surprisingly, the answer here is no type can be assigned. And it's one of these things where when you see why, you'll just be like, computers, why do you have to be the way you are? These are commas. We said the notation up here was going to be semicolons. Got it wrong. What are you going to do? So Cock will see this and be like, no, I don't know what you're talking about. Syntax error. At least here, this was very constructive. What error do we get if we leave one out? Good, right? That's nice. Okay, this might ruin the next one. Nope, good. What type does this one have? Okay. So the type of a term is made up from its parts. So if you can check the two parts separately, you'll figure it out. So over here, 3 plus 4, that's going to, well, we know actually even the answer. That's going to be 7, and 7 is a nat. Golden. So this is a singleton list holding just the number 7. Okay, nil is a list, but nil could have any type. Remember, Cock will try to guess the type for this, and it'll use contextual clues to figure out what it is. Okay, plus plus is append. Think, do you remember the type of append? Right, so we get this funny type without a for all because append's argument is implicit. But you'll notice the two lists we're appending have to be the same type because Cock lists are homogeneous. So wait, if this is a list nat, and this Cock is willing to guess and sort of figure out what type it is, and it needs to be list nat to work, okay, Cock will guess that will be a list nat, and the answer will be list nat. So just to keep me honest. Okay, notice because we defined the notation, we wrote nil, but it turned it into those empty brackets. What about here? So, what type does this have? Think about it. Pause the video if you need to. It's a bool. Wait. If it's a bool and it's the first argument for append, nah, you messed up. You messed up. Doesn't work that way. It's of type bool, but we expect something of type list X. Who do you think you are? 4. No type can be assigned. Let me also note, so earlier I ran check app. If I run check, if I run check plus plus, it's going to say, I don't know what you're talking about. And this is sort of an annoying thing about Cox notations. If you want to talk about them in terms of the vernacular commands and on their own, you have to know the function name that it corresponds to. You can't write the notation that is sort of covering up the function. FYI. Okay. What type does this list have? Pause the video if you need it. Okay, recall, in this concrete list notation with square brackets, you are naming the values of the list. You do not write another list inside unless all the values are themselves going to be lists. So let's look. Here, the first value in the list, 0th if you like, is 1, a nat. And then this is nil, which is going to be a list of some type. Those can't be in the same lists. Cock lists are homogeneous. Let's see what Cock says. Burr. So here you can see where it comes from a little bit. This is saying the term singleton list holding the empty list, which is like boop boop, the two square brackets, has type list of blah, but because I'm consing this 1 on, it has type list nat. Look, we'll get the same error message from this. See, it's the exact same error message, but now you can see, well, that's just what came out of the notation, right? If we scroll up, the way this notation is defined, x dot 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 y in square brackets is cons x, cons dot 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 dot, cons y, cons nil. So when Cox sees this notation, it just automatically turns it into that, which is why down here we get the same error message with this and with this. Both of these are ill-typed. And not like in the meaning of ill where it's cool. It's like the bad one. What about this one? Well, here now the first thing in the list is itself a list holding nats. Cool. You can do that. You can stack lists arbitrarily. It still has to be homogeneous. If your outermost list holds lists, then all the lists inside have to be lists of the same kind of thing. Right? You couldn't have a list where the first element in your list was a list of bools and the second was a list of DNA bases. But here the first is a list nat, and then the second is nil, which could be a list of anything. So process of elimination is not going to be this one. There's no bools involved. Let's leave the bools out of this. So it's really a question between these two. But list nat is a list where the list itself holds nats. Here we're a list holding list of nats. The answer is 2. We're not done yet. I apologize. I am not sorry. This is the right amount of quizzes. It takes a while to get used to these notations, so bear with me. What about this one? Well, if you remember how the list notation works, this just turns into this cons nil. So no, this is the same list as above. This is a list of nats. I'm gonna keep myself honest here. List of nat. Okay, what type does this have? Okay, this is a quiz we could have given on day 4. This is a list of bools. What about this one? This is another day 4 style quiz. This is no type can be assigned. We asked nil to have implicit arguments for the type. And here we are specifying the type. If you wanted to do that, you should have put an add on it. What about this? Last one. Okay, this is another number 4. No type can be assigned. Look, at nil says you're going to specify the type. 3 is a number, not a type. Don't be ridiculous. Okay, that's the first video. Should have a couple more coming at you soon. All right, see y'all soon.